All right, so we are on the back side of student handout 5, statements of inequality. Up at the top, inequalities can also be interpreted to make a written statement. So write in the word interpreted. You can look at an inequality and figure out what it means. It's all interpret means, right? You can read it. We could write inequalities can be read to make a written statement, but we don't want to just read it. We want to figure out what it means. So please write in interpreted. In numbers 5 through 8, we are going to translate the inequality to a written statement. So just like if you were learning another language other than English, you would need to translate it, right? So we do the same thing in math. We can look at a number statement and then write it out with words. So for number 5, we have negative 15 is less than negative 3. So we want to write that as negative 15 is less than negative 3. If your hand is sore and you're trying to save on writing, you could just write the negative symbol, but we really want to understand what that minus or negative means, okay? It's a negative number. For number 6, negative 3 is less than 8. Negative 3 is less than 8. So please write that in. And you don't have to write the actual number. I wrote the word instead of the number that time. Same for 7. Negative 9 is greater, notice it wants to eat the greater number. Negative 9 is greater than negative 21. So negative 9 is greater than negative 21. And for 8, negative 1 is greater than negative 2. So please write in negative 1 is greater than negative 2. Below there, in questions 9 through 12, place the numbers on the number line and then describe the relationship between the 2 points on the number line, okay? So in describing their relationship, we're thinking about their location and their value. All right, so here we have negative 3. Let's zoom into number 9. Negative 3 is greater than negative 9, so you can write out a little number line for yourself. You don't need to have all these lines. You could literally just have a line for 0, negative 3, and show that negative 9 is to the left. And then please write in negative 9 is located to the left of negative 3. If you want to just write negative 9 is to the left of negative 3, that's okay too. But you want to write that description out, okay? So we are describing the relationship. The directions say describe the relationship. For number 10, we have 0 is greater than negative 2.5 is how you would read this. 0 is greater than negative 2.5. So we need a 0. And again, you don't need all these little lines. You could just have 0 and negative 2.5 being to the left, okay? So you could write it as 0 is to the right of negative 2.5. For 11, negative 14/3 is less than negative 2. So again, we need a 0, a negative 2, and negative 14/3 would be somewhere over here. So after you write that on the number line, you're going to write the statement, negative 2 is located to the right of negative 14/3. Or again, you could say negative 2 is to the right, and get rid of this is located. Negative 2 is to the right of negative 14/3. For 12, 3.7 is less than 15/4. So notice these are all positive. So we have 0 on the left, and then 3.7, and then 15/4. So 3.7 is located to the left of 15/4. Now you might be wondering what these fractions equal, right? So 14/3 and 15/4. Okay, again, it's hard to compare decimals and fractions. So 14/3, you can see it, 14/3 is about 4 2/3, okay, so 14 2/3. 14/3 is 4 2/3. I can't speak. And of course that's negative, right? So it's negative 14 divided by 3 is negative 4 2/3. So that's going to be way over here, okay, compared to the negative 2. It's further left. And then again, for this one, 15/4, that's 15 divided by 4, is a positive 3.75. So here's 3.7. 3.75 would actually be a little closer to 3.7, okay? But it is to the left, okay? So 3.7 is located to the left. It's less than 15/4. Okay, so if you wanted to write that in as 3.75, you could. That's 3.75, and then again, this guy is negative 14 2/3. 4, I keep saying 14. Negative 4 2/3. That's super messy. I apologize for that. I should have done that earlier. Okay, below there, 13, based on the questions above, what pattern do you notice when a number is less than another number? So the pattern we notice, the smaller number, notice I have that in quotations because it's not really the size, like the physical size. I could write a number super tiny, then I could write another one really big, but one could have a greater value. So the smaller number is always located to the left of the larger number. You could also say the lesser number is always located to the left of the greater number. And then below that, based on the questions above, what pattern do you notice when a number is greater than another number? Well, again, the larger number is always on the right of the smaller number, or you could say the greater number is always on the right of the lesser number, okay? To summarize, I want you to draw on a number line, all right? I want you to draw on a basic number line, have 0 in the middle. If you forget that that's 0, you could even write in the word 0, okay? There's 0. And anything to the left of 0 is less. So notice this is a nice little way to remember this. That arrow almost makes the less than, or like the letter L. Less than goes left, and then greater than goes right. So write that in, draw in a little number line so you have it. If you want to write what I put in the green here, you can. So the inequality always wants to eat the bigger number and then show like a little Pac-Man dude eating a greater number. Okay, so leave that like that. All right, so give the homework a try. It's a fun puzzle, and then you can watch the homework video to check your work. Thank you all.